This is Mr. Beck Does Your Homework, AP Physics, Homework 9.1, question number 9. A particle with charge -9 microcoulombs is located on the x-axis at the point 4 centimeters, so that's this one. A second particle with charge -9 microcoulombs is placed on the x-axis at -10 centimeters, that's this one. What is the magnitude of the total electrostatic force on a third particle with a charge of 5 microcoulombs placed on the x-axis at -2 centimeters? That's this one. The Coulomb constant is. If you plug in positives and negatives into the force, into the Coulomb's law, you will get positives and negative forces answers. What I suggest you do is think about this in terms of vectors and which direction the arrows are pointing. Because if you plug in positives and negatives, you might wind up with a positive here and a negative here, or a negative here and a negative here, but those negatives aren't going to add negative and negative. The negatives are going to add in the other way. So you have to think of positive as repulsion, negative as attraction, but if you just do everything with absolute values and then think about it, it's going to work out better for you. So I've got a negative, a positive, and a negative, and I want to know what happens to this positive. So I've got a negative, a positive, and a negative. Well, this negative on this positive is going to attract it. So this positive will be pulled towards this negative. This negative on this positive will also attract it. So I'm going to get a force this way on the positive. So I'm going to have two magnitudes of forces, one pulling that way, one pulling that way. I won't know that this is left and this is right, other than looking at the picture, because both of these will give me negative values. That doesn't mean both arrows point left. But I'm going to have to figure out which one of these arrows is bigger and subtract the magnitudes and then have a final answer that's going to give me my magnitude. So I'm going to have a positive answer anyway. So I have to take these two and subtract them. If you had a positive and a negative, or a positive and a negative and a positive, or a negative and a positive and a positive, you're going to have to figure out which direction those arrows are. For example, if I happen to have a positive and a negative, well then this negative would be pulled towards that positive, but this negative would be pushed from this negative. So then the arrows are going to point in the same direction, even though Coulomb's law is going to give you a negative for this answer and a positive for this answer. The arrows are pointing in the same direction, so you add the absolute value magnitudes. So what you have to do is Coulomb's law once. So the electric is going to be K Q1 Q2 over R squared. I'll call this one Q1, this one Q2, and this one Q3. So I've got this first one, Q1, Q2. That's going to give me this value between the left and the middle. Then I'm going to have to find the electric force between the other ones, and that's going to be K Q2, the one in the middle, times Q3, the one on the end. Should be a 3, divided by R squared, the distance between these two. So my first R, since this is -2 and this is -10, that's a difference of 8 centimeters. So for this one, my R is going to be 0.08 because I got to put it in meters. Okay. This one I'm going from -2 to 4, so I've got 2, 4, 6 centimeters. So this one, my R is going to be 0.06. Now, I could probably tell, looking at it, that since these are the same magnitude on the outside, this one's going to be this one's going to be pulling more than this one. But either way, I'm going to subtract the magnitudes of the force. So find this force, I'm going to subtract them. If you have a situation like this, you'll add them.